Good morning everyone. Your subject name is strength of material. Your first chapter is Introduction to Stress, where we know about what is stress. Stress is nothing but the internal resistance against the external force. Against the external force. Stress is nothing but the internal resistance against the external force. That means if we take a material A and B, then we applied a load P, tensile load P. What happened inside? If we pour the material into this plate, what happened? In this material, what happened? We see in this material, what happened? These are the internal force, and this is the external force. External force P, and these are the internal force. Internal force. Why this is happened? Due to epsilon H equal to 0. Epsilon H equal to 0 means the body is in equilibrium condition. This is the stress. After that, we understand what is the types of stress. Types of stress. Types of stress. What happened in the types of stress? There are basically three types of stress. One is tensile stress. Second one is compressive stress. And third one is shear stress. What happened in the tensile stress? If we applied a tensile load on a material, tensile load means a axial pull load is applied on the material. The stress induced is called tensile load, tensile stress. If the material under compressive load, the stress induced is called compressive stress. If the material is tangentially, the load is acting tangentially, then the stress induced is called shear stress. These are the types of stress. What is strain? What happened in the strain? If a body is in external force is applied to a body changes its dimension. Then the ratio of change of dimension to its original dimension is called strain. Strain is equal to change in dimension to its original dimension. The ratio of change in dimension to its original dimension is called strain. In strain, what happened? We see in types of strain. What are the types of strain? Basically, strains are of three types. One is longitudinal strain, Second one is lateral strain. Third one is volumetric strain. What happened in longitudinal strain? If the material changes its length, for example, what happened? A material is this, and we applied a tensile load P. Then what happened? The material elongated. The material is elongate and changes its length. The original length is L and the change in length is del L. Then longitudinal strain is or change in dimension to its original dimension. That means del L divided by L. Del L is the change in length and L is the original length. In lateral strain, what happened? In lateral strain, change in diameter divided by original diameter. If diameter it changes, then lateral strain is originated del D divided by D. In volumetric strain, what happened? The formula of volumetric strain is del V divided by D. That means change in volume to its original volume is the volumetric strain. What happened in the strain? Strain is nothing but change in dimension to its original dimension. What happened? Types of strain, there are three types of strain. One is longitudinal strain, second one is lateral strain, and third one is volumetric strain. What happened in longitudinal strain? If the change in length divided by original length is called as longitudinal strain, and if change in diameter to its original diameter is called lateral strain, and if changes happened in volume toward the volume, change in volume to its original volume is called volumetric strain. This is the strain and types of strain. Then what we discussed, stress and strain relationship. In stress and strain relationship, what happened? First of all, we know about Hooke's law. What is Hooke's law? Hooke's law states that within the elastic limit, stress is directly proportional to strain. Means within the elastic limit, stress is directly proportional to strain. Within the elastic limit, stress is directly proportional to strain. That means, in mathematically what happened, stress, we represent stress as sigma is directly proportional to strain, we represent as alpha. Stress is directly proportional to strain. If we consider that stress equal to E into E, where sigma equal to stress, epsilon equal to strain, and E is the proportionality constant. Proportionality constant or Young's modulus. E is called as Young's modulus. What happened in the Hooke's law? Within the elastic limit, stress is directly proportional to strain is called as Hooke's law. Proportional. What happened in the elastic constant? What are the elastic constant? Elastic constant are of four types. Elastic constants are of one is Young's modulus. Second one is modulus of rigidity. Third one is Bohr modulus. Fourth one is Poisson's ratio. Poisson's ratio. These are the elastic constant. First one is Young's modulus, second one is modulus of rigidity, third one is Bock modulus, and fourth one is Poisson's ratio. In Young's modulus, what do we mean by Young's modulus? Young's modulus is Young's modulus is direct stress divided by direct strain. Basically, we tell that stress divided by strain is known as the Young's modulus. After that, what happened to the modulus of rigidity? Modulus of rigidity. In modulus of rigidity, this is the shear stress divided by shear strain. The formula of modulus of rigidity is shear stress divided by shear strain. After that, Bock modulus. Bock modulus. In Bock modulus, the formula of Bock modulus is direct stress divided by volumetric stress. Direct stress is divided by volumetric stress. This is the Bock modulus. After that, Poisson's ratio. Poisson's ratio. Poisson's ratio is the ratio between lateral strain to longitudinal strain. Lateral strain to longitudinal strain is called as Poisson's ratio, and we represent Poisson's ratio in terms of mu. This is the terms we know as this is the terms mu. Poisson's ratio is lateral strain divided by longitudinal strain. In the strain diagram of a ductile material, what is the strain diagram of a ductile material? What happened in the ductile material? If in the x-axis we represent the strain, and in the y-axis we represent the stress, then what happened? The stress strain diagram for a ductile material is this is the stress strain diagram of a ductile material, where A is the proportionality limit. B is known as the elastic limit. C is known as the upper yield point. D is known as the lower yield point. E is known as the ultimate point. After that, F is known as the fracture point. In fracture point, the material is fractured, and in E is known as the ultimate point, D is called as the lowest yield point, C is called the upper yield point, B is elastic limit. What do you mean by elastic limit? Elastic limit means, what is elasticity? Elasticity, let us know what is elasticity. If we applied a load on a body, then what happened? The body elongated. After the removal of the load, if the body is happened, what happened? If we applied a load on a body, the body elongated. After the removal of the load, if body conjugate to its original shape or size or position is known as the elastic body. That means if B point is elastic limit, that means if body tends to B position after we load is removed, it comes back to its origin. This is the elastic region. Elastic region. This is the elastic region. This is the stress-strain diagram of a ductile material. What happens in the stress-strain diagram of a brittle material? Stress-strain diagram of a brittle material. Brittle material. What happened? This is the strain. In this case, we represent the stress. What happened in the brittle material? A is the elastic limit and B is the fracture point. A is the elastic limit. Elastic limit. After that, directly is breaking point. In the ductile material, what happened? One elastic limit, proportional limit, upper end point, lower end point, ultimate point. After that, the material breaks. But in the brittle material, what happened? After the elastic limit, if we test the load, then the body is tends to its breaking point. This is the B point is called as breaking point.